Hi, Assalamualaikum warahmatullahi wabarakatuh. In the previous video, we have seen the idea of mathematical expectation, and then which can be denoted with this symbol here, E. And we started off our discussion with finding the expected value of X, right? And then based on that, what we have is we can either consider if X is a discrete random variable, then we have the summation process right here, and you're going to multiply X with fx, and fx here is the probability mass function. And if it is a continuous random variable, then we are going to have an integration process where we're going to multiply the same thing, which is x times fx, and here will be the limits, okay, the corresponding limits, the lower limit and the upper limits. Well, that is the most I think a basic idea of finding the expected value of a random variable, and our random variable is just x. Now we can make it slightly harder, or we can make it slightly complicated. If let's say you have a function that depends on x, so here we've got a function inside, and the way you want to find the expected value of a function that depends only on x is going to follow the same idea like what you have seen over here. And so instead of having x, we're going to have the summation of gx, which is this function, and it's going to be multiplied with fx. So that's the process that is going on here for a discrete case. And if you have a continuous case, you will be dealing with integration, and here we will have the same expression, which is gx times fx. Okay, so that is what we have seen in the previous video. And what we're going to see next, or in this video, is we're going to extend this concept here to include more than one variable. Okay, so here we've only got x and only got x. So now we're going to extend the idea to situations that has more than one random variable. For example, we could have x and y together. And so we're going to be interested in the function that has x and y together. And the way we can look at the formula here is, again, if you talk about the discrete case, then you'll be dealing with summation, but here we have like double summation sort of, because now we have what we have here is a joint probability mass function. Okay, so we have fxy now, and here we have a function that depends on x and y together. So here we have a double summation. Okay, now for continuous case, we can see that the same expression that is used here is seen inside this box. So we have the function of x and y. So this function here depends on x and y together. And over here is the joint probability density function. And here we're going to have a double integral process, and you can do it with respect to dx and dy. And over here are the associated limits. So these are the lower limits, and this one here is the upper limits. Okay, right. Let's look at this example right here on how we can find the expected value of this function, which is a combination of random variable x and y. Okay, right. So we're going to start off with finding expected value of x plus y. Okay, and according to the definition here, we can see that we have two random variables together. These are discrete random variables. We can see that x here can take values such as 0, 1, and 2, and y can also take values such as 0, 1, and 2. So this is a discrete case, therefore we're going to have a double summation process right here, and over here we're going to have the function gxy, and it's going to be multiplied with the joint probability mass function of x and y. Okay, so here is going to be the value of y, and y, you can see that it takes the lowest value is 0, so it's going to start from 0 and it's going to stop at 2. And similarly for x, it's going to start at 0 and it's going to stop at 2. Okay, so we're just going to apply the formula. Okay, we're just going to consider the first one is perhaps, we start off with x equals to 0. Let me just erase this part. I'm going to write down the function straight away. So the function is this one, yeah. So this is x plus y, okay. Right, so how are we going to do this? First, we're going to substitute x equals to 0 into this part and y equals to 0 into this. Okay, so here we have 0 plus 0 times with f 0 and 0. Okay, next we're just going to change this part, the inner part first. So we're going to keep on changing the values, the value of y, but we're going to maintain x at 0. Okay, so what we have next is plus 0 plus 1 times with f 0 and 1, and then we're going to keep on changing the value of y, but you have to maintain x equals to 0. So we're going to change the value of y to 2, okay, times with f 0 and 2, and we're going to stop right there because we are done up to the highest value of y. So y equals 2 is the highest point right here. And once we are done with that, then we're going to change the value of x. So x is going to be changed to 1. Okay, so 1, and we're going to start with y equals to 0. So 1 plus 0 times with f 1 0. Next, maintain x at the value of 1, but we're going to keep on changing the inside here the value of y. So y is going to be changed to 1. 1 plus 1 times with f1 1, and then we're going to have 1 plus 2 times with f1 and 2. Now once we're done with that, we're going to go back to the outer part here. We're going to keep on changing the value of x. So what's the value of x? The next value of x is going to be 2. So 2 plus 0 f2 0 plus 2 plus 1 f2 1 plus 2 plus 2 f2 and 2. Okay, so next you can see that this value here becomes 0, this one is 1, this one is 2. So I'm just going to do the process here, right here 1, and this is 2, this is 3, this is 2, this is 3, this is 4. Okay, and what's the value of f0 and 0? So we're going to look at this part here where x is 0 and y is 0. So this value is actually 1 over 6. Okay, 1 over 6. So 0 will be multiplied with 1 over 6 later. And then what is f01? So 01 is this one. So here 1 will be multiplied with 2 over 9. And for this one, f02, when x0, y2 is this one, 1 over 36. So 1 over 36. Next, 1 and 0. So when f1 and 0, you will get this value, 1 over 3. Okay, so 1 will be multiplied with 1 over 3. This one, 1 and 1 is 1 over 6. So 2 times 1 over 6. Yeah. 1 and 2, this one is the value here is 0, so 3 will be multiplied with 0. Next, 2 and 0, the probability mass function for x2 and y0 is this one, so here will be 2 will be multiplied with 1 over 12, and 2 and 1 is 0. Finally, this one is also 0, 4 will be multiplied with 0. So you will see that the final result, okay, when you consider all this process, you will be able to get that the final result of this is going to be about 1.1111, or you can also express it in terms of 10 over 9. Okay. All right, let's move on to the next example. Okay, so here is an example of a continuous case where you have the joint probability density for x and y. So here is the joint probability density, and you can see that the limits are given from 0 and 1. Here is for x, and here is 1 and 2 for y. And then you are asked to find the expected value of this function here, x over y cubed. Okay. Right, so what we're going to do next is we're just going to start off with the formula. So the formula given is actually, if you want to find e x over y cubed, so this clearly this function here has x and y together. So since this is a joint probability density, this is a continuous case, then you will be dealing with double integral, where you're going to write down this function here. So this is x over y cubed, and you're going to multiply that function with fxy. So fxy in this case is 2 over 7 x plus 2y, and you can consider the process with you're going to integrate that with respect to x first, and then you're going to do that with respect to y. So the limit here is going to be related to x, which is 0 and 1, and the outer limit here is going to be related to y, so that is 1 and 2. Okay. Right, clearly you can see that 2 over 7 here is a constant, so if it is a constant, then you can take it out. So here we have 2 over 7. And then what we can do is we can consider multiplying this this term with x. So you have x squared over y cubed, and then you will have multiply this one with this. You will have 2x and then y squared. Okay, and then this is dx dy. Okay. All right, so now we are going to do this process first. You are going to consider integrate this part first, the inner part here. So we're going to do that with respect to x. Okay, so that's what we're going to do. So we have 2 over 7, 2 and 1. Right, so what's going on right there? Okay, so we're going to do that part here. Okay, this one. So the result here is going to be, if you do it with respect to x, therefore what we have is going to be x cubed over 3 y cubed. Okay, and then here we're going to have 2x squared over 2x squared over 2y squared. Okay, so this is the result when you do this part. You consider just this part right here, and you can see that 2 can be cancelled out with this one, and here will be the limit that you can substitute later on, which is 1 and 0, and outside there is dy. Okay. All right, so we're going to substitute the values of 1 and 0 into the expression that we got. Well, we have 2 over 7, 2 and 1. So substitute 1 into x, we have 1 over 3 y cubed. And then substitute 1 into this, we get 1 over y squared. Of course, if you substitute 0 into x, the result is going to be 0. If you substitute this into this, it's going to be 0 as well. So we have this expression as the final answer for the part of substituting the values. Yeah. Okay. Next, what we have is I can write down this in terms of 1 over 3 y, this is the negative exponent, negative 3 plus y, this is negative 2 dy. And we're just going to integrate that expression given here. So the result that we get here is going to be 1 over 3. So integrate this one. What we have is y negative 2 times with negative 2. This one is y negative 1 over negative 1. And we're going to consider the limit as 2 and 1. So let me just write down this. So what we have here is we're going to consider let me just use the proper bracket. Hang on. So here we have 2 over 7 outside. Okay, therefore this part here we're going to consider substituting the limits, which is 2 and 1. Yeah. Okay, I hope that is better. Okay, right. Right, next I'm just going to continue using the space right next to it. Okay, so what we have is, well, you can substitute 2 into y. So what we have is 2 over 7. And then here we have negative 1 over 6. Okay, negative 1 over 6, this one. So 2, you can write down in terms of y squared. And then minus 1 over y. Okay, 1 over y. And then here we have 2 and 1. Okay, next we can substitute 2 into this. So what you have is negative 1 over 6 times 4 minus 1 over 2. And then you're going to minus negative 1 over 6 minus 1. Yeah. God, this is not looking good. So minus 1 minus 1. Alright, so what we have is 2 over 7. So here we have negative 1 over 24 minus 1 over 2 plus 1 over 6 plus 1. Okay, so that's what we have. And then if you punch in the values into your calculator, you should be able to get the result as 0.1786, or you can also express it in terms of 5 over 28. Okay. Alright, I think that's all for now. Thank you very much for watching, and I will see you in the next video.